Hello class, this demonstration here is for 1-point linear perspective and just a general introduction to linear perspective as a concept. So in your reading materials you should know that in linear perspective we are recreating a specific point of view to create the illusion of depth and space. We have a couple vocab terms that are very important. We have horizon line. We have vanishing point or points, and then orthogonals. I also call them just receding lines, because those are the guidelines that recede away from us to help create the correct angles that creates the illusion of things getting smaller as they recede in the distance. So we're going to start by just drawing 3 cubes. So the first thing we need to do is we need to create our horizon line, or identify our horizon line. And in this exercise, it's really easy because we can put it wherever we want. So I'm just going to kind of put it right along the middle of the page here. And I'm going to make sure it's perfectly even across my page. So I'm just going to do some quick measurements here. I'm going to put it about 8 inches from the top of my page. And then I will go ahead and draw the line across. And that's our horizon line. So what our horizon line equates to is eye level. So this is the eye level of you, the viewer, looking into the space of the picture plane. So think of it as where your eyes are located in the vertical, XY axis, right? So our eye level is right here. So if we were standing here, our eyes would align with this line here. So what that means is anything above the line we're looking up at, anything below the line we're looking down at, and anything on the line we're pretty much looking straight ahead at the object. So let's go ahead and start with some squares. When I'm starting with 1-point perspective, I start, so we'll put 1 point, start with shape. So that means if I'm trying to draw a cube, I start with a square, right? So I'll just go ahead and draw a square. And we'll do this one above the horizon line. So I'm going to start using my ruler. And I'm going to draw a 2-inch square. And it's really important to use your ruler in this exercise, because linear perspective is a very accurate tool, and if you don't use your ruler, it'll look very off. So we start with a square, and I'm going to do one on the above the horizon line. I'm going to do one that bisects the horizon line. And then I will do one that is below the horizon line as well. And I'm going to do this one, the one below, over here to the right. So I can give you a little bit more info. Okay, So we have our 3 squares. Now, and sometimes I will do this next part before I do the shapes. I will identify the vanishing point. So for this one, it's going to be really easy. I'm just going to go ahead and put the vanishing point right in the middle. And the vanishing point replicates where we are standing, right, in space on the horizontal axis. So in 1 point perspective, the horizon line is eye level, and the vanishing point is our point of view, so our location. Now, from here we'll say identify the horizon line as number 1. Number 2 is the vanishing point. Number 3 is start with the shapes. Number 4 is connect corners of shape to the vanishing point. Okay, so let's go ahead and I'll start with this one below the horizon line. So I'm going to start with the corner of my sphere, or my cube, and I'm just going to draw that line all the way across. And then I'll go to the next corner and do the same thing. And the next corner. And then we'll go ahead and do the 4th corner for funsies too here. So at the current present, this is almost like we can see through the square, right? Because we're seeing this line that is in the back edge of the sphere. But if this were a opaque sphere or cube, then we wouldn't be able to see that line. But that's getting ahead. So now we have the square receding all the way to the horizon line, which is at infinity, right? So this is a mathematical concept that helps us organize space. Like, the horizon line doesn't really exist in reality. Don't think of this as the horizon line between the sky and the ground. Very rarely in any kind of drawing do we actually see all the way to where I can no longer see anymore. Maybe on like a flat space on a long dirt road, but for the most part, it's better to understand the horizon line as sort of just a mathematical concept that helps us organize space. Okay, so now we just gotta draw the back edges of the sphere. And you simply do that by just putting vertical lines between the orthogonals. So these lines that we've put into the background are called our orthogonals. So connect corners of shape to VP with orthogonals. Yeah? And now we have a 3-dimensional cube here. Now, if we can still see through the cube, then we would just need to continue connecting with vertical and horizontal lines between the 2 orthogonals. And now notice the front line here is longer, and then this back line here is shorter. And that creates the illusion of this cube receding into space. Make sense? Great. So if you wanted, we could then go ahead and we could erase our excess orthogonal lines and we would have a cube just sitting in the space of our picture plane, right? If I went ahead and erased all of that. So you never really need to leave the orthogonals in your drawing. So because of that, what I like to actually do is, let's move to this cube right on the horizon line, is when I connect my corners with my ruler between the corner of my shape and the vanishing point, I've effectively drawn a line here, right? So I only actually have to draw my line as far as I want my orthogonal to go, and it'll just save me some erasing later. Does that make sense? Right now I can just connect that line, and now I have a cube, and I don't have all the excess lines, right? And if this were a opaque cube, like something we couldn't see through, I could go ahead then and erase the horizon line here. And then I would have my cube sitting in front of the horizon line, overlapping it, and it creates a little extra depth, right? You can start to imagine maybe this becoming a building or a house or some kind of structure, right, in space. So now I can go ahead and do my last cube, and I will go ahead and use my ruler to connect the corner to the vanishing point, and then I will just draw my line just a little ways so I don't have to erase more later, right? Work smarter, not harder. And I'm just going to do these 3 corners here because I'm not going to be able to see through my object. So I don't need to do the extra work there either. So now I can go ahead and use the same process of creating a straight vertical line between my 2 orthogonals, and then do it one more time as a horizontal line to get the back edges of my cube, and then where I went over just a little bit, I can clean those up and erase them. So now you can see, if this is our point of view and our eye level, we are looking directly at this cube in 1-point perspective. Our eye level is above this cube, so we're looking down on it and seeing the top. And then we are below the cube that now looks like it's hovering in the air, and we're looking below at it and seeing the bottom, right? Because our eye level's here, we are looking up. So that is essentially the basics of 1-point perspective. A couple other things to just kind of know. When I'm doing my vertical and horizontal lines in between my orthogonals, these lines always stay horizontal or vertical, right? These lines never angle. They always just stay straight vertical or straight horizontal. The only lines that angle and recede to our vanishing point are the lines that go away from us, right? So anything else just stays perfectly horizontal or vertical. So for example, let's say I wanted to turn this into a little house. I could mark the top of the door. Let's say the top of the door is right here at this point. I could connect that to my vanishing point, and I just mark the top of the door, and then the sides of the door would just be 2 vertical lines, right? Because this rectangle shape of the door is on this receding face, right? So we only have one line angling, technically the bottom one too, angling from us. The other 2 lines stay vertical. Let's say I wanted to put a couple windows on here. I could do the same thing. I could connect I could radiate out from my vanishing point to where the tops of the windows would be and draw a line, and then I could just have 2 vertical lines, technically 4 now, vertical lines, and I would then have my windows on this side of the building receding away. Now, if we were just doing a door on this side, there is nothing receding away from us, right? So then all we would have to do is use our ruler, and we would just draw two vertical lines. Let me make sure I'm getting this straight here. I would just draw two vertical lines. Oops. You know, we'll go ahead and make it a set of double doors for fun here. And then if I wanted to make sure that these were at the same optical height as this door, I could use my vanishing point to help guide me across, and I could mark where that vanishing point crosses the top of my door and where it meets the corner here, and then I could just project that line across, and that would be the height of my doors on this face. I could do it both ways. I could have set my height here, drawn over, and then connected, right? Do you see how that makes sense? That's why linear perspective is such a powerful tool, because I can connect height across multiple objects. So if I were to even radiate this line out further, I could have a series of additional doors that were all the same height all the way across my drawing. Now, they appear larger as they get closer to us, right? But that makes sense because it's getting closer to us, and objects closer to us look larger. But technically, these doors are the same height in real space. Like if I took a tape measure and measured this door and it was 6 feet tall or 8 feet tall, and I went and measured this door in real space, we would know that it's the same height, right? So that's how we can create scale and accuracy across multiple objects and spaces. I didn't really like how good those weren't very straight, so I'm gonna fix that. Okay, there we go. Right? I could do more doors and keep going, and the doors would just continue getting larger as the orthogonals come closer to us and the objects get closer to us in space. Okay, hey, that's 1 point perspective. Go ahead and redo this exercise for yourself, and turn your objects into little structures so you can get a sense of how to draw features on top of your cubes. All right, everybody. Good work. The next one up will be 2 point perspective.